Hello, welcome back to my classes. In this video, we are going to talk about the normal model. So the normal model is the famous bell curve, which we've seen a lot. We usually use it to describe continuous probability, which is the numerical data. Those numerical data, we get it by measuring, such as height, the weight, the commute time, or the volume. So this is going to be continuous numerical data, which is we obtain those data by measuring. Okay, so the normal model, which is look like what we're showing in the graph in here, it looked like a bell curve. The mean, for example, the mean of the rainfall in Portland is a unimodal and approximately symmetric with a mean of 40 inches and a standard deviation of 8 inches. Rounded the nearest inches enable the normal distribution model for the situation. So now in here, we want to learn how to read this part first. We learned something similar when we talking about last week. We will have a binomial distribution. In binomial distribution, the first number is the number of a child, and then the second number is the probability of the success rate. So in normal distribution is x follow normal distribution, parenthesis, the first number stands for the population mean. The second number is the population sigma, which is the standard deviation. All right, so that means in here, 40 as it states is the mean, 8 is the standard deviation of the data. So in here, usually we will label the mean in the center. The normal distribution describes the tendency of the data to cluster around the central value. In fact, the central value is the population mean. So in here, it's going to be our center, 40, which is our population mean. 14 is mu. Okay. This is always labeled in the middle of the curve, and most of the data is going to locate near the mean. So standard deviation is the characterize the spread of the normal distribution. So for example, the first one here is going to be from the mean, 1 standard deviation away. We add 1 standard deviation away. This guy is going to be 2 standard deviation away. This one is 3 standard deviation away. And then to the left is from the mean, we have subtract 1 standard deviation away, subtract 2 standard deviation away, subtract 3 standard deviation away. So to be more accurate, since our mean is 40, you add in 1 standard deviation. This is going to be 48. You add 2 standard deviation. That means you add in 2 times 8. Again, standard deviation is 8 inches. So that means this is going to be 56. And then 3 standard deviation is going to be 64. And subtracting 1 standard deviation here is going to be minus 8, which is 13.2, minus 2 times 2 times 8, which is 14 minus 16, it's going to be 24, and this is going to be 16. So how do we read this? So in this case, when we're reading this, you can think about in this way. In the center, that means the rainfall is going to be 40%. If you go into the left, that means the number getting smaller. That means you're going to have a less rainfall. So it's more likely that they're going to have a dry weather that year. And then if you go into the right, the number gets bigger. That means you have more rainfall in that year. So that means you're more likely to get in a drought. Okay, so the second part is 68, 19.5, and 99.7% root. So in normal distribution, 98% of the value falls within 1 standard deviation of the mean. What does that mean? So when you're looking at the curve, we will consider the total area, the total area is equal to 100%. So we know that the center mu is going to be 40%, and then adding 1 standard deviation is in here, and the subtracting 1 standard deviation is from the mean, and then 68% of the value, that means 68% of the data is going to be in between the first plus or minus standard deviation, which is the highlighted part contains 68% of the data. Now, the second part says, all right, about 95% of the value is going to fall within 2 standard deviation of the mean. So here is our 2 standard deviation from the mean. And the blue highlighted part is going to be contained 95% of the data. And lastly, it says about 99.7% falls within 3 standard deviation of the mean. So similar idea, we use a orange one. Let's say this is 3 standard deviation. No, should be subtract, and this side should be add. So 99.7% of the data is going to be in this area. Also, the value is more than 2 standard deviation away from the mean is considered unusual or an outliers, which means if the data is in here, let me show you. So 2 standard outside of 2 standard deviation, which is 2 standard deviation away, that means if the data is the green outlined part lies in here, which is since within 2 standard 95% of data falls within 2 standard deviation away. So that means the green part totally comprise 5% of the data, which means if the data falls in this area is considered outliers. Okay, so now let's do a very quick review. What's outliers when it comes to skill data? If the data is symmetric, we use a mean and standard deviation. Then if it's 2 standard deviation away, it will be considered outliers. Now, let's look at, I should have enough space here. Let's look at for skill data. So when it comes to skill data, when we try to describe the data center tendency and how they spread, we will use median and IQR, because these two is resistant to outliers. But still, we will still be able to find the determine which data is considered outliers. So if the data is outside of upper or lower fence, is considered outliers. So what is upper fence? Upper fence is Q3 at 1.5 of IQR. Lower fence is Q1 subtract 1.5 of IQR. So this is a quick review. If you don't remember, please go back to your note on module 2 and review that by yourself when you have time. Okay, so how do we find the probability? By using the empirical rule. So for example, in here, to find the percentage using normal model, draw and label the model and shade the area percentage that you want to find. In this case, our mean annual rainfall in Portland is 40 inches with a standard deviation of 8 inches. First, I want you to write this down so you know that, hey, these variable going to follow the normal distribution with mean, population mean is 40, standard deviation is 8. And what percentage of the term is annual rainfall between 13.2 and 48? So we know that in the middle is 40. At 1 standard deviation, it will be 48 inches. At 2 standard deviation will be 56, and then 64. Subtracting 1 standard deviation is 32. Then 24. Subtracting 3 standard deviation is going to be 16. So if the rainfall is between 13.2 to 48 inches, that means the rainfall is going to be in this area, which is 68% of the time the annual rainfall is between 13.2 and 48 inches. Now, what is the probability that the annual rainfall is more than 14.8 inches? So 14.8 inches, let's do this again. We know that this is the center. This is the mean. So 14.8 inches means this area. So how do we find out about that? So we know that normal distribution is symmetric. If we know what's the area in these two and then divided by 2, then we will be able to know the area, which is the probability that the rainfall is more than 14.8 inches. So we use symmetric property. Symmetric. Okay. All right. So we know that within 1 standard deviation is 68%. And the total area is 100%. So that means outside of a 1 standard deviation, it's going to be 100% divided by 68%. And more than 48, that means we only care about one side of the positive standard deviation. That means we need to divide it by 2, because these two shaded bar together is 100 minus 68, which is 13.4. You divide it by 2, you will get the part that we're looking for, which is more than 48%, which is 17%. Okay, so the next one is we do the same thing. 40, 48, 56, 64, 13.2, 24, 16. What percentage of the time is the annual rainfall is 24 inches less? So 24 inches less is going to be the area. That means it's outside of 2 standard deviation. Again, we use the symmetrical. So we know that within 2 standard deviation is 95%. That means outside of 2 standard deviation is going to be 100%. Subtract 95%. That gives you 5%. So within this 5%, you have 2 part is within 5%. These 2 contained totally is 5%. But we only want the left part, which is this part. This part should be half of the 5%. So that means the percentage of the time is rainfall 24 inches less should be 5% divided by 2, which is 2.5% of the time the rainfall is 24 inches less. So now, what about this case? Again, I'm going to label that. So I got 40, 48, 56, 64. Now, they ask you about what is the rainfall is 54 inches less. So 54 inches is in between here. Then we don't know exactly. You can just calculate it by guessing. So in next video, I'm going to use technology to talk about how do we use technology to be precisely to find out how to calculate the probability if it's not on the standard deviation.